Welcome, Hornets. Today we're going to be looking at the second fundamental theorem of calculus, or the fundamental theorem of calculus part 2. It's actually a corollary, and it's not difficult to understand, so let's just go ahead and jump right into it. Since we have already stated that the integration will yield the antiderivative let's do it as an indefinite integral. We get this. Don't forget your plus c, of course. Let's put it in front. But if I'm asking you to take the derivative of an integration, and I'm going up to some function, then what I need to do is remind myself that if I were to integrate this and then take the derivative, I'm going to get something unique. And that's what the fundamental theorem of calculus part 2 tells us. So let's take a look at something that will help us understand. Let's say that I have the integral, and I'm going from 1 to the sine of x, and I have t squared dt. And I want to integrate this. So let's just take a moment and integrate. We are definitely going to get 1/3 t cubed from 1 to the sine of x, which would give me 1/3 sine cubed x minus 1/3. All right, we're now going to take the derivative of this in terms of x. And you'll notice that the 3 comes out, giving me 1/3 times 3 sine squared x times the derivative of the inside piece, cosine x, minus 0. And notice what we end up with is sine x, the quantity squared, cosine x. Now let's go back and look at what we had. We have this. So you'll notice that the sine of x is going inside. So if I want the derivative d dx of a function in terms of x of something else, I'm going to get sine x inside times the derivative of the sine of x. This is the answer. Now, what did we just do? It's actually the second of the chain rule. So if you look at it, g of x, integrated a, take our derivative d dx, and we have f of t dt. We're getting f of g of x times g prime of x. And what we just found is the derivative in terms of x. That is the fundamental theorem of calculus part 2. How can we quickly take the derivative of an integral to a function? We replace the g of x where the t goes, and we make sure we multiply by the derivative of that function we're substituting, and creating the chain rule. Okay? Thank you very much, Hornets. I hope this has been helpful, and please feel free to look at it again and ask questions in class so that I can make sure that all of you get it. Thank you very much. Be well, be safe, take care, and thank you very much.